Good morning. Welcome to a nice and cool Maine morning, right? After all the heat we've been getting here. Thank you for being with us this morning, and we're going to go ahead and get started with the presentation. We have a busy day, and we have an excellent keynote talk from Ali Kelly here in just a short while. In the meantime, we'll go ahead and get started if we can get one of the slides up. Yeah. You know, as they're putting the slide up, unfortunately, this morning there was a big rainstorm up north near Jackman, Maine. Jackman is near the border with Canada. There's a big rainstorm, and it washed out a road, it's going to take a while to repair it. But the detour is 143 miles around it. Okay, so we talked yesterday about 3D printed culverts, right? And Roberto was just telling me this morning, if we had that insert in the culvert, it could have been saved. So that's an example of where hopefully we can get more innovations in there. But again, this idea, I just want to say, it came from the Maine DOT to start with. And it came to us and talked to Roberto, and that's how we get going. So when we talk about innovations, it really starts with the need, a real need. And then a team willing to go ahead and help solve that need. So again, welcome to the session. Next slide, please. Yes, if I can, this would work. All right. So our program today is very busy. Our keynote speech starts at 9:15, and the first session is an innovation panel, and I'm really looking forward to that. How do we get innovations into infrastructure? As we know, we struggled as an industry to get that in there, and that's the theme of the conference. We can have innovations, but if we don't use them, it doesn't do any good. And I tell everybody, it's great to have a PhD thesis, but it sits on a library bookshelf and collects dust. It doesn't do any good. And that's really what we don't want. And so we look forward to that discussion. We have a break then at 10:30. We have a novel composite materials and transportation session. Session 3 in the afternoon is structural composites in transportation as well. A lot of composites here. At 2:45, we have a concrete durability in an era of carbon neutral emissions. As you know, concrete's getting a bad name across the world, even though it really shouldn't be that bad compared to other materials. It's not as bad, we just use a lot more of it. And so how do we drive down the carbon emissions of concrete is an important sessions. And then this evening, the advisory board has a dinner. So this is the day 2. And again, let's see if we could, here we go. So tomorrow we start again at registration at 8, and 9:15 we have resiliency in transportation, very important topic that all of us are talking about. This morning's rainstorm, downpour that doesn't typically happen in Maine that washed out a road and 140 miles is an example of lack of resiliency in this new era of a changing environment that we're dealing with. There's some innovations in geotechnical engineering that we've been working on. I'm really looking forward to that session tomorrow at 10:45. At 1:15 in the afternoon tomorrow, we're going to talk about pavings. And then I don't think I need to tell you how important that is, particularly in our neighborhood in Maine. The freeze-thaw cycles that we have and so forth is a big issue in durability. And then tomorrow afternoon at 3 o'clock, we're going to have a tour of the Composite Center at the University of Maine. It's about a 90,000 square foot lab, and I look forward to see many of you there that would join that. Again, I'd like to recognize the Conference Planning Committee. Aaron is a co-chair. Where, Aaron? Would you mind standing up and be recognized? Thank you for all the great work. And we have Dale, James, Jim, Amanda, Vu, Jenna, and Aaron. Without them, this conference would not exist today. I'd like them to stand up and be recognized. Yeah, thank you. And the Transportation Durability Center is a UTC, University Transportation Center. And we've been around for about 3 years. But our mission is to provide a more sustainable, more durable infrastructure. And we don't want to keep replacing bridges every 30 or 40 years. Or so. And how do we do that? What kind of materials do we introduce to try to reduce that? We'll talk about that a lot today. The member universities are shown right in here in New England states, and I'm glad to tell you that University of New Hampshire will be joining our center starting next year as well. The advisory board from the DOT is an important part of what we do. What's unique about this transportation center, we want to solve real problems that real people have. And who knows what the real problems are the DOTs. So we're very connected to the DOTs. So we have a DOT advisory board, one from each New England state. And I'm going to name them here, Dale and Andrew and Ann and Christo and Gregory and Emily. And I'd like them to please stand up and be recognized. Please stand up. And yeah, thank you. And I can tell you, we couldn't do this without them. This team of very dedicated professionals are bringing the problems they're having to our team to try to solve. They're reviewing proposals and they're telling us, here's the proposals that actually we could use. And not only that, they've identified for each project, we have over 60 projects ongoing right now. For each project, that they've identified a DOT champion. What does this mean? This champion works with the researchers and meets with them regularly to say, well, maybe if you could tweak what you're doing that way, we could use it better. So basically, to integrate innovation into transportation. We're not just going out and developing a thesis and say, hey guys, here's a thesis, go figure out how to use it. What we're doing here is bringing in the DOTs at the very beginning stages of developing a technology and having them help shape what this technology looks like, so that at the end of the day, we have a customer that wants to use it. And that's an example that one of the things we're trying to do to get innovations into the transportation infrastructure. But also the ideas and the problems are problems they really have. So we're not going out there trying to solve fictitious problems. We're actually trying to identify the problems that DOT really have, and then getting champions to work with us all the way along to see if we can get to a touchdown. And a touchdown, of course, is using these in transportation. The thesis, of course, is the intermediate stage to get there. Then the transportation, the management team of the center is very well organized to allow us to work very well together. We have 4 different areas that we're focusing on in our transportation center, and each area has a lead, and you could see the lead names of each area. So Research Thrust 1 is Bill Davids, Roberto Lopez Anito is Research Thrust 2, Aaron Gallant is Research Thrust 3, and Jonathan Rubin is Research Thrust 4. I'll talk more about that in just a minute, but I'd like to recognize the thrust leaders. Please stand up and be recognized, because without you, we wouldn't be doing this either. Yeah. And those are really dedicated professionals that really want to make a difference. And then the person who really runs this transportation center day in and day out is Jim Bryce. So Jim, thank you. And Jim came to us from industry after over 20 years in the real world, and actually grew a company to over $1 billion a year, wanted to retire in Maine. Little did he know what this retirement is going to look like. So thank you, Jim, for taking on this transportation center. And then we also have Amanda Collymore and Vu Fan that are really working day in, day out, being the machine that runs the center. So Amanda and Vu, would you mind standing up and be recognized? I think they're out there. They're a machine working behind the scenes. So maybe we'll see them later. And then we also have from each university that works with us in New England, there's also a lead within the university to coordinate all the faculty working within that university. And those leads are here. So you see Ramesh and Suyong and Aaron and Mandar and Mushi Shin, and they're here. Please stand up and be recognized. And thank you for the work you're doing. Yeah. Thank you. So this is what it takes. But again, we have over 60 projects ongoing right now in all these different states, research projects. And we have over 200 students working in different areas. And yesterday you heard from the Commissioner Sheehan, is to make innovations brought into the real world, you have to do workforce development. Now, what better ambassadors of technologies than the ones that are actually developing these technologies? And hopefully those will get hired by the DOTs and by private business, and they will become the ambassadors for bringing these innovations into the real world. So see if I can get this to work. I don't know which way I pointed. I pointed to the top, to the left. Here we go. So these are the 4 research thrusts. If you're going to try to figure out how to fix something, you got to figure out what problem you have to start with. So research area thrust 1 is basically a performance assessment. How do we go out there and figure out how bad things are? How bad is a bridge is? How bad is a road? And so on and so forth. So we're looking at developing next generation tools to evaluate the status of the infrastructure. Then that information gets back to the designers of materials. Thrust 2 is developing new novel material systems to solve some of the problems we have. Thrust 3 is the structural systems. So how do we actually build a system that we can install faster and so forth? It's not just about materials, but about systems as well, structural systems such as bridges and others we can actually deploy. And we'll talk more about that. And finally, thrust number 4 is enhanced performance through innovations in safety, resilience, and connectivity. Those are the 4 thrusts. I'm not going to spend a lot of time on this, but you can see every thrust has lots of projects in it. Thrust 1 is performance assessment. You can see some drones here. We're working with Vermont and UMaine and others on actually looking at advancing drone technology to inspect bridges. As you know, there's a lot been done in that space, but there's more to be done in that space. And that's, if you're interested in that, there's a lot going on in that space, as well as wireless sensors and so forth. Second thrust is, here's examples of what we're doing with thrust 1. I'm not going to spend a lot of time on that, but thrust 2 is developing and implementing new materials and novel materials. One of the materials we talked about yesterday is the culvert inserts that actually create a Venturi effect under a culvert and increases the water that flows through the culvert by about 30+%. Again, and think about every culvert is different, right? How would you put one of these things using normal methodologies? How do you insert one of these things in a normal culvert? Since every culvert's different. What if you could go out there and scan the culvert, take that data file, send it in to Roberto Lopez Anido, and who's leading up this project on this end, and he can print an insert that's designed specifically for that culvert. With 3D printing, we could do that. With traditional construction, everyone would have to be different. So you can't do that way with traditional manufacturing. So this, you could see a 3D printed culvert insert that comes in 4 pieces. That you can insert inside a culvert. At one end, it's circular, the other end is oval, and that creates a Venturi effect and can get 30% more water in the culvert. And thrust area, this is more of the culvert right here. So thrust area 3 is new structural systems, better ways to build bridges, better ways to build foundations, and so on and so forth, with foundation systems. This is a bridge that was developed at the University of Maine, and that's been tested under this transportation center. This was a bridge built in the Grist Mill Bridge that was installed last year. On the right-hand side is a bridge leaving Maine and going to Florida, Fort Myers, Florida, built by AIT, a spin-off company from the university that's in Brewer, Maine. And this company has been so innovative. And notice these bridges. This is a 2-span bridge, 2-lane bridge and 2 spans that was all transported on one flatbed from Maine to Florida. And the reason you could do that is because the girders are so light compared to traditional materials. So you can reduce significantly your emission costs, your transportation costs. Instead of sending two trucks or 3 trucks, you send 1 truck for the bridge. And that's an example of some of the innovations that you don't need heavy equipment compared to typical construction. And yesterday, the Maine DOT actually installed the next generation of that bridge. And thank you, Wayne and Joe out there. So I'd like to please recognize them. Joe, you want to stand up? You were out there working very hard yesterday on that bridge, and Wayne and the rest of the DOT team. And you ask yourself, how do you get innovations? It takes innovators of the DOT to do that, people willing to actually try different things. And the Maine DOT has been an example partner for us that's willing to work with us. Once, of course, we've done our homework to allow these things to happen. But this is a double tub girder. So you got two girders with a thin concrete deck, precast deck. We're able to do this 2-lane bridge in 3 sections. So rather than in a segmental concrete bridge or precast concrete bridge, you may need 4 of those sections because of the weight and so forth. But each one of these, this particular bridge weighed about a half the weight of a segmental concrete bridge, 1/2. Okay, and then each panel, each one of the panels of the 3 panels was about a third less than one of the 4 panels that you would use in a concrete bridge. So it's still weighed less, So each panel weighed about what, 40,000 pounds, Anthony, roughly. We arrived yesterday at the bridge site around 2 o'clock in the afternoon. I believe the first one was installed at 10:30 in the morning. So by 2 o'clock in the afternoon, the superstructure was installed. What you need to do, of course, you need to finish it up and top it off and put a concrete deck on top of it, and that's going to take some more time. But the actual installation of the precast panels actually went very smoothly. So thanks to the DOT and the contractor that worked on it. So that's an example of where we can reduce weight. We can have longer lasting bridges. We've done some corrosion evaluation on this bridge. We've done some fatigue evaluations. We should be able to exceed the life of existing bridges. We're able to put it in faster, and the costs were very, very competitive. So this is an example of a technology, of a bridge system technology that's out there today. So I'd like to kind of close back with what happened in Jackman, Maine this morning, that we had an extreme storm that washed out a whole road. Okay, and then people have to travel 140 miles to get back home to fix the road. And Roberto said we could have avoided it potentially if we had this culvert insert in it. So how quickly can we get these culvert inserts? And I really appreciate Ann at the New Hampshire DOT that's trying that out. So Ann, I'm looking forward to see how that works out for you. And then hopefully we can do a lot more of those and get these kinds of innovation out there. Think about what it would cost to replace that road and the 140 miles of travel that the public would have to do. So having a plan to go out and replace lots of these, and in certain where we think there's going to be extreme storms where the hydraulics don't work very well, let's identify those places and go out there and have a program to go fix it. That's an example of things we can do by working with you together. So